Okay, good morning everybody. We're going to start today's class by doing an ACC for 10.3. It's in the middle of your ACC booklet. And then skip past all of the ACCs for Chapter 11 that we already did and go to the very last one and do that one. So we'll start with 2 ACCs today as our practice for getting ready for tomorrow or for Friday's test. Okay, so on your mark, get set, go. Pause, people watching this at home on video, pause your video, and I'll pause too, and then I'll come back and we'll go over them together. Okay, we're back. Pause your video for longer if you need more time. And here we go, ACC 10.3. So, first thing we want to do is we want the equation of g of f of x. So, we take the f of x function. I don't think my pen's on. Hold on a sec. There we go. We take the f of x function, which is the square root of x, and we replace the x in g of x with that function. So h of x is g of f of x, which will be the square root of x minus 1. Okay, let's find the domain of this. Now, we learned yesterday in our lesson that the domain of the whole thing depends on, well, it depends on the function itself, but it also depends on what the inside function is. And the inside function here, the domain for f of x, is that x has to be greater than or equal to 0, right? Because you can't square a negative. So no matter how h had turned out, you can't violate that domain restriction. Luckily, this one actually has the exact same domain restriction. So the domain for h of x is the same thing. X is greater than or equal to 0. So that's a pretty easy one. Okay? Any questions so far? Just keeping my eye on the chat here. Here's a graph one. I guarantee you one of these. Use the graphs of f of x and g of x to evaluate the following. All right, so f of negative 4. So negative 4 is my input on the f function, which takes me to that output of 2. So basically I want g of 2. And 2 on the g function is way down here at, it looks like negative 4, negative 5. Looks like the answer is negative 6. All right, next one, g of 1. On the g function, 1 is down here at negative 5, so I want f of negative 5. And on the f function, negative 5 takes me up to, it looks like 3. Okay, and finally, f of 0, an iteration where we plug in an input, get an output, then plug that back in as the new input to the same function. So f of 0 is 2, and then f of 2 would be 3, 4. So the answer is 4. Any questions on how I figured those out? For those of you who understand basic graphing and basic grade 10 functions, they actually, this outcome used to be in grade 10. Remember when you first got introduced to functions in grade 10? But they decided it was a little abstract for the guys who move on from grade 10 into, you know, applied and essential, and really only the pre-cal kids would ever have to deal with functions where you have to put numbers in and then put functions into functions. So this is actually, I really wanted to make sure we hit 10.3 before we finish the course and assess on it, because it's a nice little mark booster for guys who have basic algebra and function understanding. It's not particularly challenging, I think, for most students. Okay, so any questions about 10.3? If you have questions from the work booklet, we can talk about those later. Okay, let's go to the other ACC, one at the end. So the one at the end here, okay, so this is, oh, hang on. There we go. So this one's on the binomial theorem. So how many terms are there in this expansion? That's just a rule. There's always one more than the n number. So the answer here is just, the answer is, my pen's not working. Come on, pen. So the answer here is just, hang on. Tighten that up. There, did that work? Yep, 12. Okay, so that's just a fact. Hey, Sabri. Okay, so number 2, remind me later, Sabri, to change you to here. So which term is that in that expansion? Okay, so is it the first term, the second term, the third term? So remember that the formula is tk plus 1. So the k plus 1th term is n choose k times a to the n minus k. I guess you could put a times in there if you like. Times b to the k. Now, all I really care about, to be honest, is this part of it. I don't need to consider the coefficient to figure this out. In fact, because y is to the power of 1, the only way, I don't know why they gave me this much room, the only way that this could work is if k here is 2. So I kind of already know, since b is just y, right? Well, it's 3y, but again, I don't really care about the coefficient. What I know is that x to the 10, y to the 2, again, just worrying about this part, and again, not caring about the coefficient, is x to the 10 to some n minus k. Well, I know n is 7. To some 7 minus k times y to some k. And since y here is a 2, and this doesn't have a y in it, k has to be 2. So if k is 2, I have t of 2 plus 1. Therefore, it's the third term. So that one's fairly easy to figure out. I didn't have to do a whole lot of work here. If I'd have tried to find k using the x value, I could have done that. I would have said, hey, well, look at this. What would I have done here? This of course is, oh, hang on a sec. That's not a 10, that's a 2. I don't know why I put a 10 there. It's a 2. My bad, right? This is x squared. So x to the 10 is equal to x to the 2 to the power of 7 minus k. So x to the 10 is equal to x to the 2 times 7 minus k. So I can say that therefore 10 is equal to 14 minus 2k. So negative 4 is equal to negative 2k. So notice I get the same answer I did when I explored the y exponent. So that's a fairly logical one that you can do without a whole lot of work. Finally, one that takes some work. Expand this using the binomial theorem and simplify your results. Okay, so the binomial theorem says that the coefficient on the first term will be 5, choose 0, and then I take the first term, y, to the power of 5, and then I take the second term, which is negative 2 over y squared, to the power of 0. So that's the first term. I'll simplify everything later, but that's the first term. The second term has the coefficient 5, choose 1, times y, and now this number here goes down 1, and this number here goes up 1. And then I just kind of repeat the process till I'm out of terms. So the next one is 5, choose 2, 3, oh wait, I lost the squared. And then 4 and 1 becomes 3 and 2. And then next it's 5, choose 3. And then y becomes power of 2. And then negative 2 over y squared becomes power of 3. 2 more. 5, choose 4. And that's y to the 1 now. And negative 2 over y squared to the power of 4. And then last one. 5, choose 5. And then this is now y to the power of 0. And this thing gets all of the exponents. Gets the 5. So there we go. If you got that far and goofed up the simplification, we give you most of the marks. Of course, this one's going to be a multiple choice test, so we don't have part marks on this one. And I don't think we'd ask, I mean, obviously we're not going to ask you when where you expand a whole thing. We're going to ask you something more like which term is it or something like that. But there it is. There's the expansion. Okay, so let's simplify things. 5 choose 0. Anything choose 0 is just 1. And of course, anything to the power of 0 is 1. So that's a 1 and that's a 1. So the first term is just y to the power of 5. Okay, 5 choose 1 is 5, right? How many ways can I choose one thing given 5 things to choose from? Well, 5 different ways. Or you can run it through the formula if you need to, but you should probably know that anything choose 1 is itself. So this is 5, but there is a negative 2 to the power of 1 that it's going to multiply by. So you know what, I'm going to change this. This is going to be a subtract because it's a positive times a negative, and 2 times 5 is 10. And of course I have y to the 4 divided by y to the 2. So the second term is going to be negative 10y squared. Anybody not sure how I did that? All right. 5 choose 2 I think is 10, right? Yeah, 5 choose 2 is 10. You can run that through the calculator if you're not sure, but I think I remember that number. I don't have any. I stopped here and didn't finish the answer key for some reason. So, okay, so this is 10. And then negative 2 squared is 4, right? So 4 times 10, that's going to be a positive this time. There's the coefficient. And I have y to the power of 3. So y to the power of 3 over y squared squared. So that's actually going to be 40 over y, right? Cool. Next. Okay, so that's the first term, second term, third term. Now I'm on this one. 5 choose 3 is also 10. But this time it's 10 times negative 2 to the 3. Oh, that's going to be a minus this time. Right? Negative 2 to the 3 is negative 8. Negative 8 times 10 is negative 80. And then I have y squared over y to the power of 6. So that's going to be over y to the power of 4. All right. For the second last one, 5 choose 4 is just 5. 5 times 2 to the power of 4 is 18. The even power will cancel that negative. 5 times 18, or 5 times 16. 2 to the power of 4 is 16. Sorry, what am I thinking? 16 times 5 is 80, so I have an 80 again, but this time it's positive. And that is y to the power of 8 in this denominator, and y to the power of 1 in the numerator, so it's going to be over y to the 7. And then for the last term, I have a negative to the power of 5, so that's going to be a minus again. Anything choose itself is just 1. 2 to the power of 5 is 32. And then that would be, this is just 1, this is just 1. And then that's y to the 10, right? And there we go. Fully expanded and simplified. That's harder than anything I will ask you to do in the test. So if you can do a question like that, I'm probably not going to be able to stump you on this binomial theorem stuff. Okay? And if you could figure out number 4, you'd especially know that you understand what's going on, because I wouldn't do this to you on the test. Number 4 is a trick question. Anybody figure out why this one's a trick question? It's because when you expand this thing, there is no term with an x to the power of 9. Once again, I'm going to start by looking at this formula. T to the k plus 1 equals n choose k times a to the n minus k times b to the k. I don't know. I can't remember. Like 25 altogether, and that includes 10.3 and chapter 11. I think there's 5 questions, or no, maybe it's 6 questions. Yeah, 6 questions for 10.3 and like 18 or 19 for chapter 11, something like that. Okay, like I was saying, once again, I only care about which one has an x to the power of 9 in it. I don't care about the coefficient. So x to the power of 9 equals, and I don't care about the coefficient, so who cares about that? But I have to take the a term, the x squared, to the power of, this is n, right? So 5 minus k. Then I have to take the b term, which I know this 2 doesn't really matter to me because, again, I don't care about coefficient. And think about it, 1 over x, because, again, I don't care about the 2, is the same as x to the negative 1. So this is x to the negative 1 to the k. This time, these two things are the same base, so I have to combine them. And look what happens. I get x to the 9 equals x to the, when you take power of a power, you times it. So when you take power of a power, you times it. And when you multiply two powers that have the same base, you add their exponents. So this simplifies down to this. Oops. Negative 2 minus 1 more is negative 3. And then you can make this equation, right? If these two things are equal, then 9 has to equal 10 minus 3k. If you move the 10 to the other side, you get negative 1. And then when you divide both sides by 3, you get k is equal to a third. And right there, you should know you have a problem. How could you have a third of a term in a polynomial? So the fact that this didn't turn out to be a whole number means that therefore there is no x to the 9 term. So trick question. just to make sure I wasn't deluding myself when I was playing with this question earlier, I thought, you know what? I can do the same thing I did up here and actually kind of expand it just to make sure I'm not kidding myself. N is 5, so I have to start with 5, choose 0, times x squared to the power of 5. And of course, the rest of it is to the power of 0, so I'm not even going to bother writing it down. Plus 5, choose 1, times x squared to the 4, and 2 over x to the 1, plus 5, choose 2, times x squared to the 3, 2 over x to the 2. Remember, these two exponents always have to equal 5. Plus 5, choose 3, times x squared to the 2, 2 over x to the 3. Plus 5, choose 4, times x squared to the 1, 2 over x to the 4. And lastly, 5, choose 5, times x squared to the 0, which I shouldn't have bothered even writing down, 2 over x to the 5. And none of these things will simplify to have an exponent of 9, right? Because this is just 1, and so this is 1 times x to the power of 10. This is 5 times 2 times, so this will be x to the power of, oh, hang on a sec. Oh, no, yeah, that's 8. That's x to the power of 8 divided by 1, so that's x to the power of 7. And right there you could stop, right? If there was an x to the power of 9 term, it'd be between these two guys. And there isn't. So you can keep going. So let's see, that would be 5 choose 2 is 10. 10 times 4, so that's 40. And that's x to the 6 divided by x, so that's 40x to the 4, right? 6 minus 1, so 4. And 5 choose 3 is also 10. 10 times 2, that's another, or sorry, 10 times 8 this time, so that's 80. And then that's x to the 4 divided by x to the 3, so that's just x. 5 choose 4 is 5. 5 times 16 is 80 again. And then that's x squared divided by x to the 4, so that's over x squared. And then this is just 1, so that's just 32 over x to the 5. Ain't no x to the 9's in there, no place now. How do you know when the coefficient doesn't matter? Well, I know that when I'm solving a problem and all I care about is which term has this value on the variable, I don't need the coefficient to tell me which term that is, because the formula tells me everything I need to know about which term it is if all I'm looking at is the variable. Does that make sense when I explain it that way, Riley? Cool. Okay, so okay, before I shut off the video, because I was doing the ACCs here on video for the benefit of people who might miss this class, I have a little technical announcement for Friday's test. Friday's test will be in 2 parts. You can use your notes for both parts. You can use a calculator for both parts. All good. Open book, open calculator. One little trick, though. It's an EDSB multiple choice test for both parts. And EDSB is not the most sophisticated program in the world. When I'm building a question for multiple choice on EDSB, say I put the question in here, and then I put the A answer and the B answer. So I'm making a question, right? In here, actually, no, I can put a little bit of rich text in here. I can like put in an x squared or something. But you know what? As soon as I have to use like a diagram or something, I'll just probably, most of the questions I just import as pictures. So I can put in diagrams or whatever, right? The choices don't allow me to import anything, and they don't even allow me to type in something like x squared. I can't even, what is that called? Superscript. I can't even superscript. So if the choice, say that the answer that I wanted in A was 10x squared y cubed, I have to kind of go back to primitive typing symbols and type that in for EDSB as 10x hat 2 y hat 3. So on EDSB, when I want to say something like x squared, I have to type it as x hat 2. Like a primitive chunk, like it's 1987. Okay, so yeah, EDSB, EDSB's a piece of garbage. Tell your parents to make sure they vote out everyone who had anything whatsoever to do with Oh, I guess there's no point, right? Palliser's going to make all the school boards go away, so it doesn't matter. Someone somewhere in the school division, I'm sure, has an extra boat in their garage because they got kickbacks from Edsby to buy this piece of junk program. But anyway, that's neither here nor there. We're stuck using it, and this isn't that big a deal. Hopefully it doesn't confuse you when you read it. Any questions? That's basically it. The one thing that I like about Edsby, but of course there are better programs like, well, Google Classroom for one, where I could type in rich text or import pictures into the choices or anything. But the one thing Edsby does do that I like, but again, better programs do this too, is that I will randomize the questions, right? So not only will your question number one not be the same as somebody else's question number one, but I can randomize the answers as well. So if you did have, what's the word? If you did have kind of an idea that, hey, maybe I could just, very quietly have my phone beside my computer and he wouldn't notice if I texted my friend and said, hey, what's the answer to question 3? First of all, his question 3 is not your question 3, and second of all, even if you did have the right question, we've mixed up the choices. So that would make life very hard if you were trying to cheat, so don't. Not that I really have any reason to suspect you people. You've been a great class, and I haven't really caught anybody trying to cheat or anything, but it was pretty rampant in the some of the classes that used Edsby for testing, so just thought I'd give you a heads up that this is the way Edsby works. Okay? All right, I think that's all that I really needed to tell you today. We can spend the rest of the class going over any homework questions people are stuck on. I'll stop the video. Okay, so video